So hi, and welcome to Module 3 of the Research Data Management in Microscopy training resource. If you followed along, you've designed a file naming convention and a directory structure to provide meaningful file organization for your microscopy data. In Module 3, I'll introduce README files, a method of documentation that will be useful for the sharing and the future use of your data. File names should be consistent. Though they may be short, they will be descriptive, and that often means a liberal use of abbreviations or encoding of your own attribute data. And this means that a file is not likely to be well understood by others, including your future self, because you're going to be surprised how much over the course of a project you will forget. Consider the following file name. What does it mean, M01 or Z1 or IC? If you've never done meaningful work with the data, or if it is a long time since you've handled these images, then reading that file name is like reading a foreign language. Now with documentation, it's going to be easy for you and for others to understand that data set, and you won't need to stretch the limits of your memory. In this case, the M indicates that images were acquired from a medium potato, and 01 was the number assigned to that sample. Z1, the zone from which you section the potato, and IC, that the sample came from the potato's inner core. Your documentation will be valuable for deciphering these file names, and that benefit will endure over the lifespan of your data. Typically, your time on a project is going to be as long as you are on a contract, but without documentation, your contribution can carry on and on. Typically, as time you spend helping others to understand the data set, often the project lead or the next graduate student to handle the data. With documentation, however, in your absence, you can have conversations with your colleagues across time. And you'll help science. Good documentation means that others are not dependent on you, nor is the valuable time of the next researcher wasted in finding, understanding, and using a data set. So what is good practice for documenting my data? I'll introduce now the idea of the README file. A README file, or READMEs, can be considered signposts that provide concise description about some data. They may take different forms, but most often they are simple plain text documents in the file format .txt and saved immediately alongside or perhaps in the parent directory of the data. You can use READMEs to describe many different elements of your data, including changes due to image processing and analysis steps. But to keep within the scope of this training resource, we'll consider the use of READMEs only for describing your file name conventions and the directory structures. So on this next slide, I'll create README file for some microscopy data, and we'll describe it just in a very general sense. Consider this the anatomy of your README file. So in the first section, we're going to give a basic description of the data, covering the what, the who, and the why. And the first element in this case is a title for the data or data set, which also provides a brief description of folder contents. Second, provide contact details for the project principal investigator, including name, affiliation, and the email address. For graduate students, it is most likely this is your supervisor, but more generally can be considered the owner and thus the responsible person for long-term data storage. Next, add contact details for the data creator, so most likely you, and you're the person most likely to be familiar with the data set. Then include a brief description of the project, including the project objective or objectives and/or the study design. And this is information that just lets others know the original intended use for the data. So in section 2, we then describe exhaustively the file naming convention. So first, it is writing the file naming convention down. Second, using plain language to briefly describe all attributes in the naming convention. So third, provide where reasonable an exhaustive list of attribute values in the naming convention. And finally, give 1 or 2 examples of file names. And it is best to accompany the file names with a basic description of the associated specimen. Then, in the final section, provide a brief description and example of the directory structure and folder locations. This may include, as an example, the location of the raw data for archiving or long-term storage and organization of subfolders within that parent data folder. Now, I've truncated some parts of the README file on the screen, and that was just so it could fit on this slide. But in the downloads below, you'll find complete examples of README files for biological, geological, and plant sciences data, so I do refer you to those. I've also included a bare bones README template, and you can download this and populate for your own data set. And feel free to add or remove different elements as suits your own project. And it's as simple as that. The README should be saved as a plain text document, which you can then create and open later using either Notepad in Windows or TextEdit on macOS. It's then easy to share your README, which acts as that signpost to help others to find and to understand, and importantly, reuse your data. And here is an example if I were to put it all together. In my research repository, I have consistent and meaningfully named image data in a well-organized hierarchical folder structure supported by simple documentation, my README files. And when combined together, your project has a good foundation in file organization, and one which I hope can immensely increase the value of your research data. So well done. You've made it to the end of the Research Data Management for Microscopy training resource. It's now your turn to create your own README files. Remember, you can download templates below, and I wish you all the best in your microscopy-related research.